Hello everyone and welcome back to our channel. In today's video, we're going to explore the minimum function in PySpark, a simple yet powerful tool for finding the smallest values in your datasets. Whether you're working with sales data, performance metrics, or any numeric field, knowing the minimum value is essential for understanding the lower bounds and identifying outliers. We will cover different ways you can use the minimum function, both globally and within specific groups, to dig meaningful insights from your data. So let's jump right in and learn how to make the most of this useful function. Introduction to minimum function. The minimum function in PySpark is used to calculate the smallest value in a specific column of a data frame. Similar to the main function in SQL, minimum allows you to quickly identify the lowest value within a dataset. This function is particularly useful in data analysis when you need to find the minimum value in a numeric dataset, such as the lowest sales figure, the minimum temperature recorded, or the smallest profit value. By calculating the minimum, you can determine the lower bound of your data, which helps in understanding the range and distribution. The minimum function can be applied directly to a column to compute the minimum value across all rows in the DataFrame, giving you a single value that represents the smallest entry in that column. This is useful for gaining a general understanding of your data, especially when you want to identify extreme values or outliers. For example, if you have a dataset with different sales transactions, using minimum can help determine the lowest sales amount recorded. In addition to calculating the global minimum, minimum is also often used in combination with group by. By grouping your data by specific categories such as products, regions, or time periods, you can calculate the minimum value within each group. This type of group aggregation is helpful for making comparisons and understanding the performance across different segments. For example, you can use group by to group your data by region and then apply the minimum function to find the lowest sales figure in each region, giving you insights into the weakest performance areas. Overall, the minimum function is a fundamental part of data aggregation in PySpark that provides a clear view of the smash value. Whether calculating the minimum across the entire dataset or for specific groups, the minimum function helps you identify the least performing elements, set benchmarks, and make informed decisions based on the lower limits of your data. Basic syntax. The basic syntax for using the minimum function in PySpark is dataframe.groupByCols.aggregate mean column name. This allows you to find the smallest value in a numeric column, either across the entire dataset or within specific groups. The group by function is used to organize data into groups based on one or more columns, allowing you to calculate the minimum for each group separately. The cols parameter specifies the columns used for grouping. For example, grouping by category allows you to find the minimum sales value for each product category. After grouping, the aggregate function with main column name calculates the smallest value in the specified column for each group. Using group by with minimum helps you identify the lowest performing segments or extreme values within each group, providing insights into the lower limits of your data. This approach is useful for comparing categories, understanding variability, and making informed decisions based on the minimum values for each segment. Why use minimum function? The minimum function is useful for finding the lowest values in a dataset, such as the minimum price, salary, or earliest date. It helps you understand the lower bounds of your data, identify outliers, and set benchmarks. You can apply it globally across the entire data frame to find a single minimum value, providing an overview of the lowest point in the dataset. When used with group by, the minimum function calculates the lowest value within specific categories, offering insights into how different segments form. For example, you can group by region or product and determine the minimum sales or price for each group. This helps highlight variations and identify areas needing improvement. Overall, the minimum function is key to understanding the lower limits of your data, whether applied globally or within groups, and aids in making data driven decisions. Practical examples. So, finding the minimum of a single column. In this example, we have a PySpark data frame div that contains sales data for different items. The data frame consists of two columns, item and size, where item represents the name of each product and sales represents the corresponding sales value for each product. Our goal is to determine the minimum sales value across the entire dataset, helping us understand the lowest point of sales recorded. To achieve this, we use the aggregate function in combination with the minimum function. Specifically, minimum sales is applied to the sales column to calculate the lowest sales value. This aggregation provides a single summary value representing the smallest sales value recorded in the entire data frame. We use alias mean underscore sales to rename the resulting column as mean underscore sales for better readability. This makes it clear that the value represents the minimum sales figure across all transactions. Finally, the dot show method is used to display the result, which consists of a single row with one column named mean underscore sales showing the minimum sales value. In instance, if the sales values are 100, 200, 300, 400, and 500, the minimum function will determine that the lowest value is 100. This result provides insight into the lower limit of the sales data and helps to identify the least favorable transaction. Calculating the global minimum is often a key step in understanding the data distribution, identifying outliers, and setting baselines for performance. This example shows how you can use aggregate with minimum to quickly determine the smallest value in a dataset, which is especially useful for summarizing and analyzing data to understand its overall behavior. 2. Grouping and finding the minimum value. In this example, we are working with a PySpark data frame div that contains sales data for various items. The data frame has two columns, item and sales, where item represents the name of each product and sales represents the corresponding sales value. Our goal is to calculate the minimum sales value for each individual field item, which will help us understand the lowest sales recorded for each product. To achieve this, we first use the group by function to group the data by the item column. This step organizes all sales records for the same item into a group, allowing us to perform aggregation operations on each group independently. For example, all sales transactions for item R are grouped together, as are those for item B and item C. After grouping the data, we use the aggregate function along with the minimum function to calculate the lowest sales value for each group. Specifically, minimum sales is applied to each group to determine the smallest sales value for that item. This helps us understand the least favorable sales performance for each product. By using alias min underscore sales, we rename the resulting column to min underscore sales, which clearly indicates that it represents the minimum sales for each item. Finally, the dot show method is used to display the resulting data frame, which consists of three columns, item and mean underscore sales. The item column lists each unique product, while mean underscore sales provides the smallest recorded sales value for that product. For instance, if item A has sales values of 100 and 300, the minimum sales for item A will 100. Similarly, item might have sales values of 200 and 500, with the minimum being 200. This example demonstrates how to use group by and aggregate with minimum to calculate the smallest value for different groups within a data snake. Group aggregation like this is particularly useful for identifying the lowest performance or minimum value for each category in the dataset. By determining the minimum sales for each item, you gain insights into the least favorable transactions, helping to identify areas where improvements can be made and establish baselines for comparison. 3. Finding the minimum of multiple columns. In this example, we are working with a PySpark data frame div underscore multi that contains data for multiple items, including sales and profit values. The data frame has three columns: item, sales, and profit. The item column represents the name of each product. The sales column contains the sales values for each item, and the profit column represents the profit associated with sales transaction. Our goal is to determine the minimum value for both the sales and profit columns across the entire dataset. To achieve this, we use the aggregate function in combination with the minimum function. Specifically, minimum sales is used to calculate the lowest value in the sales column, and minimum profit is used to determine the lowest profit value recorded in the dataset. These operations provide important summary metrics that represent the smallest values in both the sales and profit columns. By using alias, we rename the calculate minimum values to mean underscore sales and mean underscore profit for better readability and interpretation. This makes it clear that the values represent the minimum sales and minimum profit across all items in the data frame. Using descriptive column names helps in understanding the output at a glance. Finally, we use the dot show method to display the result, which consists of a single row with two columns: mean underscore sales and mean underscore profit. The mean underscore sales column shows the lowest sales value recorded in the dataset, while the mean underscore profit column displays the lowest profit value. For example, if the sales values are 100, 200, 300, 400, and 500, minimum function will calculate the lowest sales value as 100. Similarly, for profit values of 10, 20, 30, 40, and 50, the lowest profit value will be 10. This example demonstrates how you can use aggregate along with minimum to calculate the smallest value for multiple columns in a data frame. Calculating the minimum for both sales and profit provides insights into the least favorable performance metrics in the dataset, uh, allowing you to understand the lower bounds for each metric. This type of analysis is useful for identifying outliers, setting baselines, and understanding the overall distribution of the dataset. 4. Finding the minimum with a conditional expression. In this example, we are working with a PySpark data frame div that contains sales data for various items. The data frame consists of two columns, item and size, where item represents the name of each product and sales represents the corresponding sales value for each item. Our goal is to determine the minimum sales value, but only for sales greater than 200. This allows us to focus on higher value transactions and ignore smaller sales. To achieve this, we use the when function in combination with the minimum function. The when function is used to create a conditional expression that filters out the sales values that do not meet the specified condition. In this case, when df.sale is 200, d.sales checks if the value in the sales column is greater than 200. If the condition is true, it runs the sales value, otherwise it returns null. This ensures that only the sales values greater than 200 are considered for further aggregation. After creating this conditional selection, we use the aggregate function along with minimum to calculate the smallest value among the sales that meet the condition. Specifically, minimum when df.sale is 200, df.sales computes the minimum sales value for transactions where the sales are greater than 200. This is helpful for understanding the lower bound of higher value sales in the dataset, giving insights into the smallest high value transaction recording. We use alias mean underscore sales underscore over underscore 200 to rename the resulting column as mean underscore sales underscore over underscore 200. This makes it easy to understand that the value represents the minimum sales value among transactions where sales are greater than 200. Finally, we use the dot show method to display the result, which contains a single row with one column named min underscore sales underscore over underscore 200, showing the minimum sales value for all sales greater than 200. For example, if the sales values are 100, 200, 300, 400, and 500, the minimum function will calculate the lowest sales value among 300, 400, and 500, resulting in a value of 300. This helps to focus the analysis on the higher value transactions, providing insights specific for the more significant sales data. This example illustrates how you can use conditional logic with when in combination with aggregate and minimum to perform selective aggregation. It is particularly useful for filtering data and calculating minimum values based on specific criteria, enabling more focused analysis and a better understanding of the data segments that matter most in different contexts. 5. Grouping and finding multiple minimum values. In this example, we are working with the PySpark data frame diff underscore multi that contains sales and profit data for multiple items. The data frame has three columns: item, sales, and profit. The item column represents the name of each product, while the sales and profit columns contain sales and profit values respectively. The goal is to find the minimum sales and minimum profit values for each item in the dataset, giving insight into the least favorable performance metrics for each product. To achieve this, we first use the group by function to group the data by the item column. This step ensures that all the records related to the same item are grouped together. Once the data is grouped, we can perform aggregation operations on each group independently, allowing us to find specific metrics for each item. After grouping the data by item, we use the aggregate function in combination with the minimum function to calculate the lowest values for both sales and profit. Specifically, minimum sales calculates the smallest sale value for each item, while minimum profit calculates the smallest opposite value for each item. This helps identify the lowest recorded sales and profit figures for each product, giving us a deeper understanding of the least favorable outcomes for each group. To make the output more readable, we use alias min underscore sales and alias min underscore profit to rename the resulting columns to min underscore sales and min underscore profit respectively. This makes it clear that these columns represent the minimum sales and profit for each item. Finally, the dot show method is used to display the resulting data frame, which contains three columns: item, min underscore sales, and min underscore profit. Each row shows the item name along with the lowest sales and profit values recorded for that product. So for instance, if item A has sales values of 100 and 300 and profit values of 10 and 30, the minimum sales for item A will be 100 and the minimum profit will be 10. Similarly, the results will show the lowest values for item B and item C based on the available data. This example demonstrates how you can use group by and aggregate combination with minimum to calculate the smallest values for different groups in a dataset. By determining the minimum sales and profit for each item, you can better understand the variability and performance of each product, identify low points, and make informed decisions to address underperforming areas. 6. Finding the global minimum value. In this example, we are working with a PySpark data frame D app that contains sales data for different items. The data frame has two columns, item and sales, where item represents the product names and sale represents a sales value for each transaction. Our goal is to determine the minimum sales value across the entire dataset, regardless of which item it belongs to. To achieve this, we use the aggregate function along with the minimum function. Specifically, minimum sales is applied to calculate the smallest value in the sales column for all the records in the data frame. This global minimum provides an overview of the lowest sales figure recorded across the entire dataset, allowing us to quickly identify the least favorable sales transaction. We use alias global underscore mean underscore sales to rename the resulting column as global underscore mean underscore sales, which makes it clear that the value represents the minimum sales value globally across all items. This helps in interpreting the result easily. The dot show method is then used to display the result, which contains a single row with one column named global underscore mean underscore sales that shows the lowest sales value recorded in the dataset. For example, if the sales values are 100, 200, 300, 400, and 500, the minimum function will determine that the lowest value is 100. This global minimum is useful when you want a high-level summary of your dataset, helping to identify the smallest value and understand the lower bound of your data. This example demonstrates how to use aggregate along with minimum to calculate the minimum value across an entire data frame. The result provides insight into the lowest sales transaction, which can be useful for identifying outliers, setting benchmarks, or understanding the overall performance of the data. Whether applied globally or in a group context, calculating the minimum is an essential step in summarizing and analyzing data effectively. Thanks so much for watching. I hope this video helped you understand how to use the minimum function in PySpark to find the smallest values in your data. Whether you need to summarize your entire dataset or analyze specific categories, the minimum function can provide key insights into the least favorable outcomes and help guide data-driven decisions. If you found this tutorial helpful, don't forget to give it a thumbs up, share it with others, and subscribe to our channel for more PySpark and data analysis content. Feel free to leave any questions or suggestions in the comments below, and I'll see you in the next video. Keep learning, keep coding, and happy analyzing.